According to Occupational Safety and Health Administration regulation, hearing protection device should be provided when harmful workplace noise or sound level exceed 85 decibel. Thus, in this case study, we are focusing on airport worker. Hearing protection device that provide to airport worker consists of two equipment, first earplug and second earmuff. In this case study, we specify on earplug. This is how we relate to a method of making a hearing protection device, in particular a method of making an earplug which consists of an elongated core and outer layer. The use of earplug device is well known in heavy-duty manufacturing field. Earplug partially or completely construct of a foam material that are inserted into the ear canal of user to physically obstruct the passage of sound wave into the inner ear. In material selection, we have four strategies how to select the best material to produce earplug. So, strategy 1, translating. Translating, we translate a design requirement expressed as function, constraint, objective, and free variable. For the second strategy is screening. So, by using the constraint, we construct the stiffness versus density graph. From that, we have 5 material that can be used to produce the earplug. So for the third strategy is ranking. We rank the material using objective. This is how we find the screen material that do the job best. So from that, we get the top score for the polyvinyl chloride material, and we rank as a number 1. So for the last strategy is documentation. This is how we seek supporting information by research the family history of material. We found that polyvinyl chloride is one of the most common material used to manufacture earplug.
Now we'll look at the process selection analysis. In this case study, we'll focus on the shaping process of an earplug. Strategy 1. Translating is done by translate the process requirement in 14, function, objective, constraint, and free variable. Strategy 2. Screening process is done by examining 5 process chart. First chart, process mass range chart. The estimated mass of an earplug is set by 0.001 up to 0.1 kg. Second chart, process range of thickness chart. The thickness of an earplug is not parameterized because earplug is in 3D solid shape. Chart 3. Process tolerance chart. The tolerance of an earplug is set by plus or minus 0.5 mm. Step 4. Process surface roughness chart. The surface roughness of an earplug is set by A level. Fifth chart. Process economic batch chart. The batch size of an earplug is set by 100,000 units. After the screening process, we can conclude that there are two routine processes which are injection molding and compression molding for fabricating an earplug. Strategy 3. Ranking process is done by examining the cost model. As we can see here, compression molding is less expensive compared to the injection molding, but injection molding can be done in multiple units in one shot, and these two curves intersect at this point, 10,000 units. Thus, injection molding is selected. Strategy 4. Documentation. Injection molding process for earplug is done by reciprocating screw machine. This machine will help the polymer granules to be fed into multiple cavities, and then this polymer is solidified under pressure and the components of an earplug is then ejected.
Hello doctor, my name is Muhammad Farid and I will explain for manufacturing process for earplug. For the primary shaping process, the mold includes a first cavity that limits expansion of the outer layer. The second cavity in the form of stem portion. The first cavity is oriented below the second cavity. Next, for the outer layer is thermally bond to the elongate core. Outer layer and elongation core of earplug is shaped in a mold prior to expansion during secondary process. Later, elongation core of earplug is formed by extruding the material. The elongate core is cooled and will cut to the desired length for an earplug. Later, the elongate core is covered with an outer layer comprising a second material. For secondary process, heat was applied to a portion of the outer layer. This method includes the step of extruding the first material to form elongate core. This includes a shell of hydrocarbon or other appropriate gas. This expansion of the thermoplastic shell results in an increased volume and reduced density of the material of outer layer. This can be controlled to provide an earplug having a sound attenuation portion and stem portion, exhibiting a desired shape, density, hardness, and other desired characteristics. For the finishing process, earplug is subsequently cooled and rejected from mold. Finished earplug includes a sound attenuation portion which done by the shape of first cavity of mold, and a stem portion which done by the shape of second cavity of mold. That's all. Thank you.
Hi, I am Putra and I will be explaining the flowchart of the production process. So product is hearing protective device which is called as earplug. So we start from the raw material which we use polyvinyl chloride or called as PVC. It will undergo the primary process which is injection molding. The shape of the earplug is determined from the cavity of mold. The shape must be perfectly following the mold cavity. If it's not in desired shape, it will be sent back to injection molding in the primary process. If it in the desired shape, it will go to the next process, which is heat treatment. The product will undergo the heat treatment, where it includes the step of extruding the first material to form elongate core. If the part is not being heated properly, the process is repeated on the heat treatment. If yes, it will move using conveyor to the next workstation, which is quality check. If the part is not approved, then it will be sent back to injection molding to the mold back. If yes, then it will go to the packaging and barcode scanning. Then it goes to logistic workstation before sending out to the warehouse. Thank you.
Today I will proceed with the effect of parameters on earplug. As we can see from this slide, there is three parameters that we considered. Consider word as our parameter, it is because earplug requires feeders of light weight to reduce the pressure exerted on the inner ears of the user. The second one is compressive strength. Compressive strength is required to prevent failure from stress applied to the earplug. Is stiffness. Okay, for this one, to facilitate a proper insertion, the stiffness should be maximized in order to provide us with a fuller insertion. In this section, there is 7 parameters that we considered. Okay, the first one is material. Okay, for the material, TP-PVC is selected. It is because TP-PVC is able to provide sufficient stiffness and compressive strength to fabricate an earplug. And then the second one is shape. Okay, for shape, injection molding is selected to shape a 3D solid shape of an earplug from a raw material of TP-PVC. Okay, the next is part mass. Okay, for part mass, earplug is designed by a very small product mass. So this parameter is limited by the process capability. Okay, the fourth one is maximum section thickness. Okay, maximum section thickness is not prioritized as the shape of the earplug is in 3D solid shape. Okay, the fifth one is tolerance. Okay, for tolerance, a limited tolerance is needed to ensure that the earplug does not slip or dislodge before expanding enough to stay in a place. Is surface roughness. Okay, for surface roughness, injection molding process is able to produce a good surface roughness, which is a grade A. So it will provide compatibility usage of the earplug for the end user. Okay, the last but not least is the economic batch size. Okay, economic batch size affect how much of the product needs to be processed and marketed to keep up with the production cost. So, this injection molding has a strong economic batch size that is mitigated by the growing consumer demand for an earplug. Okay.
Hi, Dr. Zaleha. Next is testing and quality control. Quality control is to ensure the quality of the hearing protectors. The protectors should fulfill the construction and performance inspection listed by the standard for industrial hearing protectors. There are three methods of testing that need to be complied the earplugs to maintain its quality. For first method is method of testing effectiveness. Effectiveness of ear safety that calculated by TTS or temporary threshold shift of hearing using audiometric approach under noise action. For second method of testing, which is method of testing shape and comfortability. Comfort is the psychological simulation and deciding factor for the systematic use of ear protectors. Excessive abruptness under ear cups will cause discomfort and unpleasant sensations. Last but not least is the third method of testing of noise reduction rating. The highest noise reduction rating or NRR that currently offered by an earplug is around only 33 decibels. So, the measured values of correlation coefficient obtained by TTS using MIP should show that strong positive and reliable relationship at space frequencies. Thank you. Hi, Dr. Zaleha.
Good day to Dr. Zaleha. My name is Lai Mom Wei. I would like to present about the type of defect and its countermeasure. The type of defect have categorized into three parts, which material, process, and skill. From material, we found that it causes ear infection due to regularly clear ears. They should use eardrop to soften the earwax. Next, earplugs are no longer flexible. This issue can be solved by choosing the material which have maximal lifetime and high flexibility. From process, we can see that the size of the earplug does not fit to the ear canal. This causes the difficulty to insert and remove it. We can choose form push to fit type to solve it. Next, noise control field. The fit test is necessary since the noise reduction rating it have the connection with protection. Lastly, most of the workers lack the skill and knowledge. Training and conference on noise hazard should give to the workers. For example, correct use and proper way of earplugs. As a conclusion, personal protective equipment is important since the safety is the major issue. From our case study has resulted the best material and process to produce the good quality of earplug. There have some improvement have been suggested to give a good overview of earplug. The above is our presentation. Thank you.